Well, that looks beautiful. We got some interesting little color tower here today. It's kind of cool. I'm going to go over here. I'm going to try something over here with this water. I'm going to try to develop that tower, but I'd like to make the rainbow a little larger. You know, there is a rainbow here that runs from red to violet. I want to get those bands a little larger. I wonder if I can do that. So I'm just going to get this stir bar going here. Let's add some universal indicator. It's also known as rainbow indicator. It displays different colors depending upon pH. All right, you'll see here it starts out in a green color. And this is my tap water, and it looks like my tap water, it turns the universal indicator color, the universal indicator a green color. That just means it's neutral. It's neither acidic nor basic. My tap water is generally neutral. Just gonna add a bit more to get some color. There we go. Here, I'll show you the pH scale. Here's the different colors that you will see the universal indicator display. You can see that nice green, boy, a beautiful forest green. That indicates pH 7, right smack dab in neutral. This one over here, in this flask, that's kind of cool, isn't it? The other flask, that has a huge pH gradient in it. So we start at pH 3 up here, and then it moves to like an orange. It's really hard to see the orange band, which is like a pH of 4 or 5. And then it moves to, I'm going to just change this lighting a little bit so we can see the paper just a bit better. There we go. And then we move to like a greenish color. And then down on the bottom, it's violet. So yeah, you can see the different colors, where they're going to be the different pH indicators. I'm going to go ahead and let's add some acid to this. The acid I'll add is hydrochloric acid. It's the same acid that's found in your stomach. It's just that this is a lot more concentrated. Thanks for the likes. Appreciate that. My tap water seems to be buffered. And what that means is it resists changes in pH. So as I'm adding the acid, you know, we started at like a pH 7, and now we're just down to pH 6 with a couple drops of acid. It's taking a few drops here to get that pH to drop. Let me add another drop there. The acid I'm adding is hydrochloric acid. And you can probably notice as I continue to add drops, the color shifting from like an orange, a yellow to an orange. I mean, you can see right where I add the acid, it gets a nice red color. As the indicator changes, as the pH changes, and as I continue to add these drops of acid, a little more, little more. Welcome aboard. Just doing some science experiments, taking any questions about chemistry you might have. Hello there, KT bros. Welcome aboard. Thanks for saying hello. All right, I think we've got that. That's kind of an orange. That's just maybe pH 4. I'm going to add one more drop to get us to pH 3. There we go. I'm going to turn this off now. And then I'm going to add just one drop of base. We're going to see what happens, okay? Just one drop. Base I'm adding is 20% by weight, sodium hydroxide. In it goes. Well, you know what? I'm going to wait a bit until this stops spinning so much. Let's look over here on this one. Isn't that cool? This is the effect I'm trying to get. So this flask, I just set up the same way. But what I did is I just added a drop or two of the sodium hydroxide. And then, of course, it produced this pH gradient. I'm going to go ahead and turn this on. And here's the deal. If the acid and base are perfectly balanced in this flask, then we're going to end up with a forest green colored solution when we're done. If there happens to be more acid, we're going to see one of these colors because there'll be an excess of acid. If there happens to be more base, we'll see a blue or a violet because there's more base. Here we go. Let's mix it up, see what happens. Here we go. Probably more base. Oh, yeah, there's a lot more base. Definitely a lot more base. Let me just add a few drops of acid here as it's going. We'll try to neutralize the base. I'm adding drops of acid up here at the top. Oh, that's pretty. We got some nice colors going on today. Beautiful colors going on today. Very nice. A little bit more acid. Actually, quite a bit. It does look like a tornado. It looks like a rainbow tornado. I'm going to add a drop of base here. 1, 2. There we go. Oh, not quite. 2 more. 1, 2. Let's see if we got enough base to make some color changes now. Come on, baby. Get a little drop so you can get the rainbow. There it is, folks. A rainbow tornado. All the colors of the rainbow in the flask. Briefly at once. It is mystical, magical. All right, we're going to back this up so we can see both flasks. Over here, this flask on the right, I'm going to go ahead and add a drop of sodium hydroxide. Here we go. Boop, and it goes. You can see where the sodium hydroxide goes in. It's like a violet color. The sodium hydroxide solution I added is more dense than the surrounding solution, which is why it drops. It does look like from another galaxy for sure. Let's go ahead and add a few more drops of acid over here on the left in the dynamic system. We'll call this one, I mean, they're both dynamic. They're both changing. But this one's changing much quicker because I'm stirring it. This one over here, I'm not. Boy, that's just kind of hanging out, isn't it? I'm going to add another drop of base over here on the right. Just one more. I think we might have this system set up where we're going to see an interesting, hopefully we're going to see a rainbow tower over here. I wonder how much the sodium hydroxide would change the color over time. You know, we're kind of finding that out over here. We kind of are. I might have to give it another drop of base, but we're going to see. We're going to see. Here we go. Let's add another drop of acid over here. A couple drops, get it nice and red on the left. And then I'll add some base. Let's see if we can get a rainbow tornado. Here we go. 1, 2, 3. Let's see what happens. How you doing, NRM? Glad you're hanging out with us. Glad you're aboard. We're getting a little rainbow developing over there on the right. I'm going to add another drop. Just one more. There it goes. You can see the base sink. Oh, yeah, we've got a nice rainbow developing over here. Just beautiful. Kind of like a static rainbow on the right. We're trying to get a dynamic rainbow over here on the left. It's a little tougher to do. I'm adding a bunch of acid right there. Let's see what happens. There we go, a little flash. It's easy to get red and violet at the same time. Thank you there, KT Bros. I appreciate it. We'll go ahead and add a little bit of base over here. 1, 2. Come on, man. Give me the rainbow. It's a slow roll through the rainbow, huh? Through all the colors. Look what we got over here. Isn't that nice? It's really nice. I'm just going to start shooting in a little bit of acid, a little bit of base. We need a little more red, so in goes the acid. Yeah, look at that rainbow tower we have, folks. Beautiful. Really pretty. Really pretty. All right. I think maybe this system is just being spun a bit too fast. I'm going to slow the speed down just a bit. Now we're going to drop in some base. Yeah, we've got a nice rainbow tower over there on the right, folks. Really looking nice. Look at that. Isn't that beautiful? You can see kind of the red bleeding down along the sides. Oh, yeah. Look at that. Come on, man. Look at that on the left. Look at that on the left. Pretty. Pretty stuff. Oh, yeah, I can see a rainbow, an orange band. So it's like red, orange, yellow. There's a tiny green band, a tiny blue band, and then your violet band. I got something else I want to show you here today. We're going to try it. So yeah, how folks doing out there? The echo chamber is saying Goofy, breaking the echo chamber. Love the name there, breaking. Love the name. Gorgeous. It's like a slow roll through the rainbow. Very nice. Very nice. I'm going to just rotate this a bit and see what kind of difference we see as I rotate the flask. Look at that. Just gorgeous. Really nice rainbow going on. It is weird, like the red is kind of bleeding down, but it's that's a decent rainbow tower. Yeah, pretty cool. All right, let's add some acid over here on the left. So here you go. I'm adding acid to universal indicator, so we definitely should see the pH dropping down to pH 3. The acid I'm adding is hydrochloric acid, same acid that's found in your stomach. Now I'm going to add a little bit of base, which will neutralize the acid. That should raise the pH, and that should shift our colors from red, maybe to orange, maybe to yellow, maybe to green. And if I add enough base, it should get us all the way down to violet. Get a little flash there, the rainbow. Let's try 2 more drops of base. I'm really liking this effect over here. Hey, give me a thumbs up if you want to see me mix this thing over here on the right. Give me a thumbs up if you want me to see me do that, huh? Or give me a rainbow emoji if you just want to leave it the way that it is, all right? You let me know, folks. Trey wants it mixed. We got to vote for mix. Are you adding these colors into water? Yes, I am, NRM. Uh-oh, Arjun says leave it at the rainbow. We got 2 votes because Kickin says thumbs up. Rusty says thumbs up. KT says thumbs up. That's enough. That's, what is that, like 4 or 5 to 1? Here we go, baby. Let's you got it, KT bros. Here we go. Let's mix that baby up. Science is definitely the best, Arjun. All right, we're mixing. We are mixing. Is there more acid or base? 3 to 1. Thanks for the tally there, KT. And oh, it's yellow. So there's just a bit more excess acid in there. Yeah? See, we're at pH 6, so there's just a bit more acid. What's going on, Angry? Thank you there, Humphrey. Here we go. Let's start adding some. How you doing there, ZYX? Here we go. I'm going to add acid to both of them. Get the pH nice and low. And then we're going to try to make the rainbow in both of them. We're going to try to get the double rainbow. Acid for the win, says Rusty. Here we go. A couple drops of base. 1, 2, 3, 4. 1, 2, 3, 4. Let's see what we get. Let's see what we get. We got a little rainbow over there on the right. Come on, baby. We got the rainbow on the right for sure. Looks like there's something goofy going on over there on the left. But we definitely had the... Oh, no, we got a little rainbow action over there on the left, too. It just took a little while longer to develop. Very beautiful. Yeah, the tornado is bigger on the right. Let's see. That's probably because I'm spinning this faster. Yeah, this one's actually a smaller stir bar. This one's larger. Let me get this both going at roughly the same speed. So they're both going at roughly the same speed. I need to center this one over here. It's going off the... There we go. Can I make the mixing things max speed? Angry British. I'll do it, but this is what usually happens, all right? Let me try to center it. It usually knocks a stir bar out of orbit when I go max speed. We're going to try it, though. Actually, I think this one's got a better chance. So here we go. I'm turning up the speed right down here. Over here, I'm turning up the speed. I'm at like 80% right now on the left. I'm turning it up here on the right as well. We are really moving. We're about 90% on the left. I'm doing it slow so it doesn't knock it out. Oh, we're getting close. Ah, there it goes. I knocked it out of orbit. Got going too fast. Sorry about that. Let me just try to center it a little better. That might help. Over here on the right, we're getting close to max speed. Up there it goes. It got knocked out of orbit. There. I think I might have it centered well on the left. I'm messing around down here trying to get that stir bar just right. Excuse me. Ah. Sorry, y'all. I don't think it's going to work today. Pardon me, I got something caught in my throat. Thanks, sir, Angry British. Yeah, this one is just... Anyway, here we go. Back to adding acid or base. Here we go. A couple drops of base over here on the left. A couple drops of base over here on the right. Thank you there, Angry British. Ooh, man, that's pretty. That is pretty for sure. So what's going on here if you haven't seen it before? I have two different flasks. Both flasks have some universal indicator added to them. Universal indicator is also known as rainbow indicator, and it changes color depending upon pH. So you can see over here on the left, I'm adding base to the flask on the left, and as I do that, the red color is probably going to shift to a more orange as the pH goes up. Yeah, Angry British, some of them have. Some of my students figure it out. Get a little drop over here on the right. I've got all sorts of pretty gorgeousness happening here today. Can you turn the base into smoke? I don't believe so. I apologize. I'm not sure what question you're asking there, Phobia. There we go. Well, not this one, because this is, I think I might know what you're talking about. Excuse me, this base. No, I'm not a wizard. Yeah, I wish there, Shreed. Oh, that's funny. You might be talking about the reaction between ammonia and hydrochloric acid. That will turn something that looks like a little bit of smoke. You too, Phobia. All right, let's do another experiment. Hello there, LUV. Hello there. I'm going to do another experiment here. What's going on, Dre? I'm 100% a nerd. Absolutely. How you doing there, Huddy? Yeah, drop a nerd emoji in the chat to celebrate the nerdness of Tommy Technetium. 100%. How you doing there, NYC? That's cool to hear, Muhammad. I agree, Nick. It is very beautiful. I don't have any barium chloride with me there, Shreed. But, you know, your counter ion in those cases are both the same there, Shreed. So I don't think much going to happen if you mix barium chloride with sodium chloride. There you go. I'm loving the nerd emojis. Thank you, Jennifer. Thank you, KT. I'm doing fine, NYC. Huddy, great to see you. Hello, Creesh. I can't, Dre. I'm not that kind of chemist. I'm not a synthetic chemist. I'm a physical chemist. I wish that, Angry British. Come on, that'd be great, wouldn't it? So I have dropped rubidium in water. That's as far down the alkali metal table as I've gone. I've dropped... Thanks there, Huddy. Oh, great, girly. Please say hello to your kids for me. I love it when kids get interested in science. So yeah, I have put... Nick, we can try it. Nick says we should put lights in the bottom and do it in the dark. We can give it a shot. Why not? Can I do an example of unknown identification with some transition metals? That might be fun at some point. We got someone in from Russia. Yeah, I got stuff we can drop in here. We're going to try this. Somebody said let's just go in the dark, and we're going to try this. I've never done this before, but we'll give it a shot. Somebody said, hey, let's put some lights in the bottom. There, I got a little LED here, color changer. There we go. Man, we're going to turn off the lights. Okay. Here we go. I don't know if this is going to work or not. There, look at that. Okay. And I'm going to pour some water in here. Oh, it's floating. I knocked it over. I knocked it over. Let's see if we can get it straightened up. There we go. You know what? It kind of looks better that way anyway. And I'm going to turn this completely off. There we go. Look at that. I got to turn off the light in the other room so it's completely dark in my basement. Oh! There we go. Give me a second. I got to turn this on so I see where I'm going. There we go. We got a little color changer and some light. Color changing light. Do I have any double displacement items? Oh, man. Yeah, that's right, KT. Hey, Jennifer, that's great to hear. Me too. Me too. There you go. Somebody wanted to do that particular experiment. Looks kind of cool, doesn't it? A little bit of LED light and water. It's just kind of fun. Changing colors. Just pretty. Just fun. Yeah? Might be able to hear the train running by my home. All right. Let's get back to business here. Get back to doing some acid-base reactions. Put the light in the other one. Okay, here we go. I'm going to turn this off. All right, here we go. What would happen if you dropped a match in the big jug? Nothing. It's not gonna explode or nothing. It's all right, here we go. There you go. We got a light in the other one. Hey, thanks, Jennifer. That's great to hear. Now, that's going to be hard to get out now. It looks like it's flickering, doesn't it? Looks like it's... Let's turn these lights off just for a second, see what kind of beauty we have. Might as well... Oh, look at that, huh? What the heck? I think we're seeing like a... Yep, we're seeing some residue on my glasses. All right, here we go. I'm going to start adding... what am I going to add? I'm going to add a little bit of acid over here to the one on the... Yep, that's acid. Here we go. Let's make this acidic. I'm adding in acid. I don't know if you can see it or not. Probably not. Without the backlighting. Oh, yeah, you can see it a bit. You can see the acid dropping down. Could I do oxalic acid and sodium hypochlorite to show an example of what not to do? Yeah, I know, KT. I'm going to have to just kind of, I'm just going to have to dump out the water. Let's put a couple drops of base in now and see what happens. A little bit of interesting beauty effect there, huh? Kind of cool. Yeah, I'm going to turn on the front light here so I can see a little better what's happening. That's what it looks like. It does look a little bit like a lava lamp. Over here, we just got plain water. Over here, I got universal indicator and a little LED down at the bottom that I'm going to have to get out later. Kind of fun. That's what folks wanted. Do I only teach chemistry? I have taught courses other than chemistry, but mostly what I've taught throughout my career is definitely chemistry. Yeah, that's what we're seeing here. Definitely like a lava lamp. Okay, I'm going to try a little experiment here. I don't know if you all have seen this before. Let's pop this off. Kick in, what a great idea. Unfortunately, I don't have any fluorescent dyes on hand. So that is not going to work. All right, let's try this experiment. Where's my flask? Here we go. You guys are going to like this. Where is it? Here we go. Okay. Let's put this here. I'm going to get the backlighting going again so things look a little better. There we are. Looks prettier. Okay. And this flask over here on the left, I am going to add some essential water, which you'll notice here, they say the pH is 9.5 or higher, okay? They sell this stuff as alkaline water. It irritates me. They say this alkalizes your body, which is just ridiculous, but nevertheless. We're going to take some of this Essentia alkaline water, okay? And I'm going to pour it into this flask over here on the left. So in goes the essential water. And there we go. We're going to go ahead and add some universal indicator to the essential water that I just added to that flask. So here we go. Let's add some Essentia. Some of the craziest reasons I had to tell a student off. Not really. Sorry, man. All right, let's add a little bit of universal indicator to our essential water and look at the color it changes to a violet. And so that's as advertised for sure. You know, they say that the pH is 9.5. And that, that tracks with what we know about our, I don't have any of that, Shreed. There we go. We can see both there, Shell. So here I got pH 10. And, the essential water claims that it's, pH 9.5. You can see it right there, pH 9.5 or higher. It's a little hard to see. It's hard for the camera to focus on it. Anyway, here's what I want to show you. I'm now going to exhale into this with a straw. And let's see how much carbon dioxide, how much carbon dioxide, that's what I exhale, right? Actually, only 4% of what people exhale is carbon dioxide. We don't exhale 100% carbon dioxide. It's only 4%. I'm going to go ahead and exhale into this. And let's just see how much blowing through this straw it takes for me to neutralize or maybe even acidify, get down to pH 6 or so, the essential water. Remember, yellow color is going to be pH 6. All right, here we go. Well, there it's neutral. And there it's acidic. So, this idea, that wasn't even one full breath. So this idea that essential water is somehow going to alkalize your body, the carbon dioxide you produce in less than one breath not only neutralizes the essential water, but even acidifies it, which is kind of crazy, huh? So there you have it. Yeah, we do it at the end, the angry. Well, I flip the camera around at the end and I talk to folks. So that'll be coming at the end. I'm going to get this stir bar going. See if we can get the stir bar going in the... Oh, yeah, we can. Oh, no, not too well. I was trying to get the stir bar going in the flask with the LED. See if we can try it again. What chemical is the indicator, asks Shell. It's a mixture of indicators. Let's go over this. So the indicators, the dyes, I should say, that are present in universal indicator, happen to be quite a few different ones. I'm going to go ahead and let me pop this off because this isn't doing much. Let's get a fresh one on. I don't have any Sprite, Ashley. I wish I did. I definitely wish I did. There we go. Let's get this on here. Can you see your arsenal of equipment? Sure, I'll show you some of this stuff. Hold on. So yeah, you can just, here's all that stuff there that I got. There's my lighting in the back. Here's some stuff I got over here. Here's some other things I got set up. Here's my shelf of stuff. I got some Coke and Mentos ready to go if I feel like doing it. There's my wizard hat. That's the setup, folks. But I keep it focused on this cool looking stuff here like this. So there was a question about what are the chemicals present in the indicator. And here we go. It's thymol blue, methyl red, bromothymol blue, and phenolphthalein. And the mixture of those four, the mixture of these four gives you, your universal indicator. So yeah, those are the four that are in there. I do have some baking soda, British, but it's up in the, it's upstairs. I don't have any downstairs in the lab. I should probably bring some down here at some point. Let's add a little bit of base here. Yeah, I did get I got a YouTube Shorts plaque. I also had the Silver Creator Award. Hey, and we're inching up towards, we're getting close to 700,000 subscribers. So thanks to all of you who choose to just subscribe. It's very, it's appreciated for sure. I guess my channel, I've had people, I guess I could do that, KT. No, my vacuum chamber buddy's not here today. Not here today. Is there any chance you could run get some baking soda? I'm probably not going to go get the baking soda right now, Angry British. Sorry about that. Maybe mix universal indicator and hydrochloric acid. That's what I'm doing right now, Ashley. Bring baking soda to your next live, and then you'll sub, KT, huh? This is much more convenient, Shell. Much more convenient. So there you go. I've added a bunch of hydrochloric acid to some universal indicator. And now we're going to add base. Let's see what happens. What if I add Mentos to the mix? We could do an experiment with Mentos. There's an experiment I do where you can see the bubbles up close. It's kind of fun. Let's do that. Let's see if we can get... I've not done that. Hello there, drama. I've not done that in my lives before. Let's give it a shot. Why not? I've got the stuff. So hold on. We're going to do it. Okay. What do you mean? How am I going to do this indoors in my basement? Well, we're going to show you. This little thing that I invented. Okay. Add demon core to the glass. Come on, man. I don't know, Dre. I don't know how to do that. I'm not a synthetic chemist, so I apologize. I'm not the person to ask. I don't think it's too difficult, though, from what I understand. Here we go, baby. We are going to do some Coke and Mentos. And what I'm going to do is I'm going to add this little, I've got like this really long tube. See this really long tube? It's like what is it? It's more than a meter high. All right. Got a, I attach it to a little tornado tube. We're going to stick it up here on top of my Coca-Cola. And we're going to drop a Mentos in, and we're going to be able to see it go. Oh, man, that's a little tall. I'm going to have to get up on the... oh, that's going to leak. That's totally going to leak. I guess it won't be that bad. We'll give it a shot here. Let me just kind of squeeze this down. So you want to see how to make one of these. I describe how to make these in some long-form videos. That's about as best as that's probably going to leak. And what we want to do is we want to focus in on the foam. All right? Hydrochloric Diet Coke. And all this does, these nucleation sites. So there's a bunch of pits and pockets on a Mentos candy that allow, that allow the carbon dioxide to escape quite easily. So I'm going to drop this in, and we're going to see if we can see the bubbles up close, all right? All right, here we go. 3, 2, 1, and it goes. And there goes your bubbles. Woo, baby. Look at that thing go. It's going to go out the top. Oh, not quite. Not quite. No, I don't have any elephant toothpaste, Kim Jong. How high did we get? We got close to 110 centimeters high. Look at the beauty of the bubbles, huh? Look at that. Isn't that gorgeous? And what's cool about that is, each bubble is, I'm looking, it's roughly, I'm going to say on average, maybe 3 millimeters in diameter, maybe a little bigger. Well, if you know the diameter of the bubbles, yeah, and you, let's see, we know the diameter of the bubble, so we can find the volume of the bubble on average. We know it went up to 110 centimeters high. I know the diameter of the tube is 2 centimeters. Well, I can take the volume of the cylinder, that's the volume of the foam produced, and I can divide that by the volume of the bubbles on average, and you can find out how many bubbles are made. Pretty, isn't it? It's a little hard to see the bubbles down here at the bottom. Let me try to get a little better lighting on it because they're really small close to the bottom. Give me a second here. Let's see if we can get the lighting on it so you can see it better. Yeah, I'm having trouble. I can see him there. Yeah, universe. I've done the calculation. It's an estimate, but you know, it's on the order of magnitude, somewhere around 5 million bubbles per liter of Coke. I've written an article on that, of all things. Goofy, man, you all want to see that again? Huh? Give me a thumbs up if you want to try Coke and Mentos again. We'll do it a second time. Look at all those gorgeous bubbles. What I like about this is that, you know, you can run the reaction a number of times. And, you know, it works out. It was fun, universe. You know, you can run it a bunch of times and it goes kind of slow. What am I going to do with that Coke now? Well, I guess I could drink it, huh? Look at those gorgeous bubbles. Yeah, there we go. So, yeah, you know, I'm not going to do the math right now, but you can do it. You know, if you have an average of, we'll say 5 millimeters for the diameter of a bubble, about half a centimeter. Probably a little smaller than that, but nevertheless. And then your cylinder is going to be, you know, pi r squared h, where the radius of the cylinder is about 1 centimeter, and it went up, what was it, 110 centimeters high. You get the volume of the foam, divide that by the volume of your average bubble, and you can calculate how many bubbles we made. Pretty cool, huh? Pretty cool. Pretty cool. I don't have a calculator. I'd do that right now. You'd eat the bubbles and drink the Coke. Love it. There we go. Back to Kim Jong. I'm gonna make Diet Coke and Mentos toothpaste. It's just as good. That's what we just got done doing. A little bit more of this, huh? A lot of bubbles. Definitely a lot of bubbles. Add acid into the Coke to release the CO2. Well, let's see. We can do that. I'm imagining most of the CO2 came out anyway, right? Because probably not all of it. Boy, these Coke bottles they sell now are really flimsy. It makes it tough to get this bottle off. Yeah, I'm having trouble. I'm gonna make a mess if I get this off. I'm gonna try it though. Let me get these gloves off, and I may be able to get the. We're gonna try it. We're gonna add a little bit of acid to the Coke to see what happens. Then I can't drink it though. Oh, there, I got it. Okay. So the suggestion is to add some acid to the Coca-Cola to see if it'll release. See if it'll release the carbon dioxide. So here we go. I'm going to add some hydrochloric acid. It usually does. If you add acid to a Coca-Cola, it should release some of the CO2. However, I'm thinking we got most of it out anyway. So here we go. Let's add a little acid in here. Yeah, you can see I've added quite a few drops of acid. And I'm not seeing an increase in the kinetics of bubble release. The molarity of the acid, I think it's somewhere between 3 and 6 molar. So it's 20% by weight, which I think is 6 molar. So it's, you know, it's good and concentrated. What do you say? You guys want to do another Coke and Mentos reaction? What volume is 77 centimeter cubed, KT? I think you got some work to do there. If you're telling the volume of the foam we made, it's going to be pi, which is 3, times the radius squared, which is 1 times 1, times the height, which is 120. So 3 roughly times 120, that's about 360 centimeters cubic centimeters. All right, here we go. Let's do another Coke and Mentos experiment. Shell, I'm just doing math in my head, Shell. So I'm not going to do 3.14, you know. All right, let's do it again. I'm going to do the Coke and Mentos with my pals, my YouTube pals. We're going to do Coke and Mentos with my YouTube pals. Here we go. And we're going to use my special Coke collector, foam collector. Here we go. Here it is. It's a tornado tube that's duct taped to a really long tube. This tube is like a meter, like meter 0.2 in height, all right? And I attach it to the top. Yeah, I do. I see some of his stuff, but to be honest with you, I'm spending so much time making videos, I don't have much time for watching YouTube. So the diameter of KT, the diameter of the bubbles is about 3 millimeters. The diameter of the cylinder is about 2 centimeters. So the radius of the cylinder, like this cylinder here, the radius of this cylinder is 2 centimeters. And so half of that is going to be about a centimeter. So the diameter of this tube is about a centimeter. And the foam went up to, I guess it wasn't 120, it was about 110 centimeters high. So 110 times 1 times 1, that's 110, obviously, cubic centimeters. But then we multiply that by pi, and we'll get roughly 330 cubic centimeters. All right, here we go. The bubble KT, on the other hand, that's going to be about 3 millimeters, or 0.3 centimeters, which is going to be 0.15 centimeters cubed. That's going to be the difference, KT. All right, I'm putting this on here. We're going to check out the bubbles that are made. I'm doing my Coke and Mentos experiment with my YouTube pals. I got to get this nice and tight because if I don't, it makes a mess. And it's really hard with these new plastic bottles they use. They're really not, they're not that sturdy. Okay, I got that about as tight as I can. So here we go, just so you can see the setup. I've got a tube attached to my Coke and Mentos system. Yeah. Oh my! You know what? Let's try it over here. Let's try it over here. We can see it a little better, eh? We'll just try it set up here. Who knows? I'll put it right there. I probably should have a white background. I'm gonna get the lighting a little better. Let's see here. It's horrible lighting, but at least you can see what's going on, huh? Let's get it all the way. We want to be able to see the whole system. There we go. All the way up to the top, baby. Come on now. All right. Let's get some light on the subject so it just looks just a little bit better. Next time I'll try to use a white background so we can see it a bit better. And we're going to try to run the Coke and Mentos experiment indoors and see what we get, all right? So again, remember, the radius of this cylinder is about 2 centimeters. Excuse me, the diameter is 2 centimeters, so the radius of this is about 1 centimeter. And these are centimeter markings up the tube. So it's like, a meter's right here, 1.1 meter, 1.2, 0.9, 0.8, so forth. All right, here we go. We're going to drop into Mentos. We're going to see what happens. Let's see what we get. Calculate our foam volume. 1, 2, 3, go. Look at that, baby. Let's see how high it gets. Come on, where are we going? 80, 90. Whoa, that almost fell over. We got up to about 95, yeah? Got about to 95. We can see the bubbles. They're beautiful. Look at those bubbles. Sorry, I'm a little behind on the comments. Let me try to scroll update. We didn't quite make it to 100, did we? Isn't that cool? It's beautiful to see those bubbles. Yeah? It's kind of fun. Let's look what it looks like down here at the bottom. There they are. Those bubbles are really tiny down there at the bottom. Really tiny. Up here at the top, they get a little bit bigger. A little easier to see. Yeah? It's pretty, though. Trying to keep it in focus. So, yeah, so we got up to, we got almost a meter high. We get to like 95. You can hear it, too. Yep, going down. What time is it for me? It's about, I don't know, 3 o'clock or something like that. All right, I'm going to lean this back because I do not want that to fall in my basement. Goes for a while, doesn't it? That's what I like about this system. All right, well, how long have we been going here? About 47 minutes? I think it's getting time to end the live. I've been staring at a screen for long enough. Plus, I got some experiments I'm trying to film. Some new stuff I'm trying to get going on my channel. Hold on a sec. Let me get this back over here. So, yeah, we'll flip the camera around here for a bit, talk to folks, and see how you all are doing. Okay. Can you fly using Coke and Mentos? Probably not. Kim Jong, man, that's pretty late. You should probably get some sleep. Yep, let's flip her around. Hello, everybody. Oh, that's cool, universe. I'd love to see that. I would definitely love to see that. Thank you, Kim Jong. Appreciate it. Yeah, look at that. You got that little atom there. Right there. I think I got a buckyball down here in the corner. A little buckyball. It's gorgeous, isn't it? Did not expect me to look so British. What does that mean? What's it mean to look British? I don't understand. I'd fit in perfectly over in Great Britain, huh? What's the molecule? There's a bunch of different molecules on here, but this one is Buckminster fullerene down there in the bottom. Buckminster fullerene. It's like it's a bunch of carbon atoms that are situated on the vertices of here in America we call it a soccer ball, but in Europe you call it a football or a football. Yeah, I get that a lot, Jennifer. I have sort of a Midwestern accent. Me too, Ashley. Molecule by molecule, atom by atom. Really? That English British kid, his brother got the molecule for nicotine tattooed on his back. Well, KT Bro says it's football. Well, yeah, hey. I get that a lot. I say aluminum. I hear a lot of people say aluminium. They get upset when I say aluminum. I wish I could British, but I cannot. I can't do the British accent. My kids can. My kids are so good at doing that kind of stuff, not me. Hey, let's do it. Let's do a poll, huh? Drop the black and white football in the chat. If you think that is what should be called football, and drop the American football emoji in the chat if you think that should be called football. What made me come up with my YouTube name? I like alliteration, honestly. And I thought technetium was a good idea to use as my name because technetium's an element that covers like a whole bunch of science. So obviously chemistry, it's on the periodic table. It's like the first synthetic element. Like we say it's not found in nature, but it's not produced naturally on Earth. Nevertheless, it is found in nature. It's radioactive. Well, what do I mean by it's found in nature? Well, what I mean by that is during supernova explosions, some technetium is produced. It just doesn't last very long because it's radioactive and it decays fairly quickly. It doesn't take long for it to decay on geological timescales. So it hits some astrochemistry or astrophysics. It hits some medicine. Technetium is used as a medical imager. It's radioactive, so it hits some physics. It's got some chemistry, and because it's used as a medical imager, it's used in biology. So it spans a wide swath of science. And for that reason, I think technetium is well fitting for my interests. I love all of science. That's right there, Universe. Although Universe, recently, and I don't quite have this exactly right, but I think gold recently they discovered can happen when two neutron stars collide. If I'm, Google it, folks. Correct me if I'm wrong on that, but I think I remember recently that folks figured out that gold is produced on the collision of some neutron stars. Somehow, neutron stars are involved. Whoa, what did I just do? I used a green screen. I've never done. I messed up. Oh, there we go. Hey, that's cool. Might as well put Richard Feynman in the chat with me. I just learned how to do this. I'm gonna have to do that again in the future, man. Oh, that's fun. That is definitely fun. Hey, I don't know if y'all saw this. But I met Bill Nye, man. I met Bill Nye. He was at one of those Comic-Cons lately, and I got to hang out with him, which was kind of fun. Thanks there, Danny. I appreciate it. Okay, thank you there, KT. So KT fact-checked me, and I was right. Gold is produced by the collision of neutron stars. That's some quite recent finding. Well, hey, folks, thanks for hanging out with me this afternoon. It was a lot of fun. I hope to. That'd be nice. Yeah, I hope to see you sometime. On another live. And thanks for hanging out today, doing some experiments. First time we did some. I did. Kim Jong Vsauce did shout me out. One of my videos, which was really exciting for me. That's totally true. But yeah, thanks for hanging out here with me today. And hey, you know what, folks? The universe is always having a party. And science gets you on the guest list. Think about that. Let me know what you think about it. All right, folks? We're going to see you next time, okay? So long.